Hello, my name is Chooks. I'm an engineering student at the Georgia Institute of Technology, and today I'm going to be teaching about calculating forces based on point charges. And I'm going to run you through an example. I'm going to use the problem from my first exam as an example problem and run you through it to make sure that you don't make the same mistakes that I did. So as you can see here, the problem gives us two charges and two R values to work with. And starting off, when you see an R value, you're gonna know that you have to calculate an R hat. So you may as well just find the magnitude and find your R hat initially. Part A of the question says that we should calculate the electric force on an electron located at the origin, and that our answer must be a vector. Some keys to success, make sure you fully read the question, because I actually lost several points on this question because I didn't fully read it. As soon as I saw force, I jumped to the Coulomb's law, but that's not the equation I was supposed to use. I was supposed to use the equation for the electric field and use the relation F equals QE to find the force that way. And then also watch your signs. That's one thing that also tripped me up as well. As you can see here, this is our equation for the electric field, and we're going to use these for both charges in both instances. Starting with the first one, as you can see here, 9 to the 9th is the value of K. This is the charge value they gave us, and this is our R squared, which is the magnitude of R. And that multiplied by the original R vector gives us this value here. And we follow the same procedure where we multiply by K, the charge, divide by the magnitude, and then multiply by the R vector itself to get this value here. Now that we have two values for the electric fields, what we want to do is we take E net to add them together. We want to take E net, as I said before, use the relation F equals QE to find F net. So we add them together. We added these two electric field values together to get this value here. So this is net electric field here. And then finally, we go to the relation that I was talking about before. We use F net equals Q E net, multiply by Q. And this goes back to fully reading the question, because it actually stated that you wanted to find it for an electron, which is why Q here is negative. So you multiply out and get this value here as your final answer. For the second part of the question, it says determine where to place a positive charge Q3 equals 1.2 times 10 to the negative 5 coulombs. So the net force on the electron located at the origin is 0. Now thinking about this, for F net to be 0, our E net also has to be 0, which means that E1 plus E2 plus E3 is equal to 0, which can help us find E3. So E3, if we move this to the other side, E3 is essentially just a negative of E1 plus E2 added together, which gives us this value here. Again, reading is very critical because I rushed through this part of the question. This is actually where I missed the majority of my points, because I didn't understand the concept, or I thought they were looking for a different force, and I jumped in and tried to justify it by using Coulomb's law, but it's very important to read here. After we find the value for E3, we have to find the magnitude of E3, right? Or sorry, the R hat, the E hat vector. In order to find, we use the electric field vector to work backwards and find our R value, which is what we're looking for. So we find the magnitude, and then we also find the magnetic field, or sorry, the electric field divided by the magnitude, and to give us this. And then we essentially rearrange this equation. As you can see here, E3 equals KQ over R magnitude to find to find the magnitude of R, which if you plug in basically all the equations that if you plug in all the variables that we had previously, that'll give us 2. Therefore, your R vector is equal to R, the magnitude of R times R hat, which is equal to 2 times r hat, which we found before previously, which is right here, negative 0.8, 0.6, and 0. And that gives us negative 1.6, 1.20. But you have to be very careful because this is actually not the final correct answer. Because this r value here is from the position 3 to the origin, but we're looking for the r value that is from the origin to position 3, which is the opposite of this. So the negative of this, which is the value here, 1.6, negative 1.20, is the final correct answer.